Hi everyone, my name is ZHERN Liang. Today, I would like to share about my internship in these video presentations. During my internship, I was located at ITW Maritime Sdn Bhd Plant 2, which is located at Penang, Malaysia. ITW Maritime is the subsidiary of Illinois Towards ITW, a global engineering conglomerate. ITW Maritime is known for their electronic component packaging for semiconductors and precision devices. The core strengths for ITW Maritime are their strong expertise in polymer engineering and precision molding. ITW Maritime also adhere to JDEC, ISO, ASTM, REACH, and ROHS standards. At the same time, ITW Maritime operates under ITW's 80/20 business model, emphasizing high impact performance and efficiencies. These are the production department hierarchy in Plant 2. Leading us are Business Unit Manager Mr. Tan. Following him are the production manager, Mr. Yong. Under Mr. Yong, there are two process engineers, Mr. Uing, Mr. Rosni, production staff engineer, Mr. Sarasbong, superintendent, Mr. Nasrun, and production superintendent, Mr. Savaraj. Under Mr. Sarasbong, there are production coordinator, Ms. Tevisha. While under Mr. Nasrun, there are supervisor in charge, mold technicians, and inspectors. There are several core products produced by ITW Maritime. Among the products are JDEC tray, wafer packaging system, tip and rail system, shipping tube, maxi grip, and specialized flexible protective bags. While JDEC tray are the products produced in Plant 2. My supervisor during my internship are Mr. Silas. His job title are production staff engineer, and he was placed in production department for over 5 years. His main responsibilities are process optimizations, production planning, quality assurance, cost control, and automation integrations. His key expertise are process optimizations, data analysis, and material development. During my internship, I was assigned to production department. I observed and involved in daily manufacturing operations. My main project is to develop the inspector incentive system. I also involved in technical and analytical tasks and assist with process documentation and improvement. The overall manufacturing operation flow started with crushing and mixing of the materials. Following that is drying, injection molding, inspection, annealing, packing, and shipment. There are additional processes such as flipping and siltering required for specific parts and also materials. My main project during my internship is the development of inspector incentive system. The objective is to improve the inspection productivity, consistency, and motivation. This project is also to address the performance variations due to part complexity, fatigue, and motivations. This inspector incentive system helps to maintain high product quality while improving output efficiency. This project is also carried out to design a fair and transparent performance evaluation system to identify key performance indicators, KPIs for visual inspector, and to develop a standardized scoring methods based on the inspection data. This inspector incentive system aligns with ITW 80/20 principles, which is to focus on high impact improvements. For this inspector incentive system, 1 month of inspection data is collected, such as date, part number, inspector number, and average output per hour. The benchmark, which is the highest inspector daily performance of different part numbers, is used for fair comparisons. Following that are the development of the scoring formula, which is the 60% for average output score to determine the consistency and productivity of the inspector. 20% of benchmark score is to compare the relative performance between the inspectors. At the same time, 20% of difference part score is to determine the flexibility and adaptability of the inspectors. This system is also integrated with quality control checks, with only inspector with score greater than 80% are eligible. The inspector with missed detection of trade defect will be disqualified. At the same time, absent without valid reasons will lead to 10 mark deduction. The data of this project is analyzed using Excel dashboard, bar chart, and trend lines. The expected impact of this inspector incentive system included higher inspection efficiency and morale, reduced performance variations, and to promote accountability, fairness, and continuous improvements. During my internship, I involved several technical and analytical tasks. First and foremost is the inline defect trend analysis, which is to identify the recurring defects and their correlations with machine, shifts, and product types. I collected daily rejection data and plot trend charts, which the major defects are short shots, opaque, and blisters. I found that the short shots are the common in specific molds and shifts due to inconsistent setup or material conditions. The actions taken are to optimize molding parameters and strengthen preventive maintenance. Next are the inline mold technician analysis, which is to evaluate how mold technician performance affect the rejection rates. The data is grouped by technicians, machine, and part numbers. I found out that the variation is due to difference in temperature control and purging practice. The recommendations are to standardize setup procedures and implement peer verifications to reduce variability. The offline inspection performance analysis is the foundation of the inspector incentive system. This analysis is used to assess the inspector efficiency and accuracy during production data. The metric used are average output per hour and defect detection rates. I found out that high output not necessarily equals to high accuracy. Therefore, a balance is needed between productivity and quality. The data produced in this analysis is used to assist in fair scoring criteria for the inspector incentive system. I also involved in tray blister defect study, which is to investigate the root cause of blister defects in PPE trays. These defects is usually caused by the excess moisture and high barrel temperature, which is due to vapor entrapment. The suggested solution is to extend the pre-drying durations and reduce front zone temperature. Throughout the study, I learned that there is a strong link between material drying, thermal control, and surface quality. I also involved in PAS tray surface morphology study, which I analyzed PAS tray surface morphology under different molding conditions. SEM, which is scanning electron microscope, is used in this study. I found out that optimal screw speed and temperature will produce smoother surface, while poor control will lead to microvoids and uneven texture. Therefore, minor process variations will have major impact on surface quality and performance. During barrier temperature and hot tip optimizations, I studied the effect of temperature setting on melt flow and filling quality. I also adjust the barrel and nozzle temperatures to observe the flow variance and surface finish. The result shows that uniform temperature will lead to stable process, while the use of hot tip will reduce gate defects. Therefore, precise thermal management ensure consistent product quality. I also involved in moisture-related defect investigation. I explore non-destructive testing (NDT) for moisture and internal defects in geometry, such as ultrasonic C-scan, spectrography, and infrared thermography. Throughout this investigation, I understand how NDT helps detect internal defects and improve quality control. Other than technical and analytical tasks, I also involved in documentation and improvement. For process control documentation revision, I updated and revised injection molding parameter and control documents. I reviewed the existing record and added new parameters such as lot number. I also reorganized the layout for better clarity and usability of operators. The outcome is to ensure accurate, traceable, and updated process data, and support troubleshooting, quality consistency, and process optimizations. Overall, it improved document usability and standardization for future reference. During my internship, I also involved in a new tray cleaning machine installation with a China vendor. I act as a translator between the vendor and local engineering team and also observe testing and troubleshooting during installations. At the end, I document all issues and corrective action faced during installations and gain practical exposure to equipment validations and communication handling. Other than that, I also involved in load number and line bind off study, which is to improve the product traceability and data consistency. I analyze the production and inspection record for compliances and correlate log data with inspection results to ensure alignment. At the end, I understood the role of documentation accuracy process validation, and data integrity in quality assurance. I also learned how small process deviations can impact overall product quality. Lastly, I also assist in production layout improvement, which the observation is focused on operator movement, tray handling, and equipment placement. These tasks contribute to workflow efficiency, safety, and process excellence. And I learned how continuous improvement and documentation support productivity. I have learned a lot throughout this internship. In terms of technical learning, I gained practical experiences in data-driven process improvement and performance evaluations. I developed strong skills in root cause analysis and defect trend identification to enhance product quality. This internship also helped me to deepen understanding of polymer material behavior, molding parameter, and their effects on product performance. I recognize the importance of accurate documentations, process standardizations, and parameter control in ensuring consistent manufacturing outcome. While for professional learning, I strengthen communication and collaboration skills through a close teamwork with engineers, technicians, and inspectors. This internship helped me to improve my technical presentations and report writing ability through project documentation and performance reviews. It also enhanced my time management, adaptability, and problem-solving skills in a fast-paced production environment. Last but not least, I gained insight into ITW's 80/20 business model and continuous improvement culture, emphasizing focus on high-impact activities and operational excellence. That's all for my sharing about my internship. Thank you.